Hello and welcome back, future scientists. I'm Mr. K with Mississippi Public Broadcasting, and we're going to continue our lecture today talking about the science portion of the ACT and how you might be able to bring up your score by a couple of points. What I wanted to talk about today is graphs, and we're going to introduce some of the different types of graphs that you'll see and the types of questions that go along with them and some of the different types of figures and diagrams that you'll see in the science portion of the ACT. A lot of the questions in the science portion of the ACT deal with graphic literacy. So talking about this might really improve your score because you'll kind of have a little bit of background information that you can use when you're taking that ACT for real. Okay, so let's go ahead and get into, this is kind of Graphs 101. This is some very basic stuff, but if you can't figure this out, you're not going to be able to answer any of those other questions. Let's make sure we're laying a strong foundation before we get to more complicated stuff. So let's kind of zoom in on these and I'll walk through them with you and see if we can kind of figure out what's going on here. Okay, so different types of graphs are featured on the science test. Bar graphs and line graphs are the most common. Students should get familiar with analyzing graphs to easily extract information. Key elements of graphs on the science test include the following. They are often identified, graphs are identified as figures, so figure 1, figure 2, okay? The x-axis usually represents the independent variable, while the y-axis typically shows the dependent variable. Graphs displaying multiple data sets will include a key or clear labels. Again, finding that key for multiple data sets is very, very important because it orients you and lets you answer these questions more quickly, but also you know what you're looking at and you're more likely to get them correct. Students should understand the importance of consulting the key on a graph. ACT research found that students weak in graphic literacy frequently ignore this important feature. Students should also note the values on each axis and what axis represents and what each axis represents. Okay, so more information today. Now we'll talk about bar graphs. So bar graphs are frequently used to compare different categories of data, with each bar's height or length corresponding to the value it represents. One axis of the graph specifies the category or types of data being shown, while the other axis displays the actual values. Bar graphs are often used when the independent variable isn't a number, but rather a category like a location, experimental group, or some similar factor. If the independent variable is numerical, the values might be spaced at uneven rather than regular intervals. So next up is line graphs. Line graphs are often utilized to illustrate how quantity changes in relationship to another or to compare multiple data sets. Line graphs are used a lot to show change over time as well, okay? Let's talk about general graphic literacy skills. And this is specifically talking about being able to identify patterns, okay? So you should develop the ability to identify common patterns within data. For instance, you may observe that when one variable increases, the other often does as well. In line graphs, this relationship typically manifests as a positive slope that rises from left to right. The data may exhibit a linear, exponential, or other trends, depending on the specific scientific phenomenon under investigation. While this data could be represented in a table, line graphs or scatter plots effectively communicate the information, and putting it in a line graph makes it easier to find that trend very quickly. So again, when it rises in a positive slope from left to right, that means it is a direct relationship. And if there's a direct relationship, you're probably going to get a question about it. If it does the opposite of this, if it's a negative slope and it goes down from left to right, then that's probably an inverse relationship. And if it's a very strong pattern, you're probably going to get a question about it. Okay? Let's talk about these two terms, extrapolation and interpolation. Okay? So when a trend in data is clear, students may be tasked with extrapolating or predicting an unknown value by extending the existing trend. Conversely, they might need to interpolate, which involves estimating an unknown value that lies between two known data points based on the established trend. These two skills, extrapolation and interpolation, these are very high level skills. So if you're not quite hitting those really, really high scores on the ACT, these might be two things that you want to work on. Basically what's going on here is it's using a graph and trying to predict where a imagined scenario might lie. If it lies in the graph, it's interpolation, and if it lies outside the boundaries of the graph, it's extrapolation. Okay, so that's kind of the difference. This is within the data, and this is kind of outside of the data. Okay, but there's some important information you need to know when you're doing these. Okay, when you're doing extrapolation and interpolation, in both scenarios, the unknown value could potentially be an anomaly. However, the ACT sign test assumes that this value will align with the established pattern. Students should feel confident in selecting the most plausible answer under the assumption that the data point adheres to the trend. So that last sentence is kind of the most important. You need to assume that the data points adhere to the trend. So just because, let's say you have this line graph and it's a positive slope, it's going up like this, if it's asking you a question that lies beyond the boundaries of that graph, just continue the trend, and that's going to help you answer the question. They're not going to ask you something if the trend totally changes, right? They're assuming that whatever pattern is there is going to remain in that same pattern beyond the boundaries of the graph, okay? Okay, let's talk about this extrapolation and interpolation in a little bit more detail. So for example, if a question asks students to use a graph depicting rainfall the past 20 years to predict the flowing year's rainfall, the science test will not mislead students by presenting an answer that deviates from the established pattern. Students can trust that there won't be an unexpected year with significantly high or low rainfall. The trend at the end of the data range is assumed to persist beyond the displayed range, maintaining the same general slope. Similarly, in interpolation questions, only one answer will typically fall within the specified range. Okay, so really what's going on here is that if you can find that trend or pattern, you can use that to insert data points that they're imagining. So they might ask you, they might say, presume or imagine if this other trial was done, where would it fall on this graph? Well, you just need to find where it would go within that trend, and that's going to lead you to the correct answer. Okay. Lastly, I wanted to talk about diagrams. Okay. So there is a limit to the complexity of information that test takers can reasonably absorb from a passage. Therefore, diagrams may be utilized to help illustrate studies or experiments. It is advantageous for students to familiarize themselves with various types of graphs, since it is nearly impossible to predict the specific details of any given graph that may appear. It is more effective to concentrate on developing a general approach to understanding diagrams as a whole. So these are some things that might increase your science skills. These are ways to take a graph and to practice them and make sure you can get as many of those questions correct as you can. Your teacher has some other work for you to do today, so make sure to give that your best effort, and I hope everybody has a great day.